This is Phobos, the innermost and larger of the two natural satellites of Mars. Meaning fear in ancient Greek, it is irregularly shaped with a mean radius of 7 miles and is 7 times larger than the outer moon Deimos. It orbits Mars much faster than Mars rotates and completes an orbit in just 7 hours and 39 minutes. As a result, from the surface of Mars, it appears to rise in the west, move across the sky in 4 hours and 15 minutes or less, and set in the east twice each Martian day. From clouds to craters, this image from Mars Express shows a beautiful slice of the red planet from cloud-covered northern polar cap to contrasting hues of the northern hemisphere and crater terrain in the south. In the south, near the equator, is an incredible region called Arabia Terra, a huge plain about 4,500 kilometers wide. This area has a crater called Cassini, which itself is over 400 kilometers across. Whatever hit Mars to form it was big, way bigger than the dinosaur killer that hit Earth 66 million years ago. The north polar cap in the top is mostly water ice with dust mixed in, with a thin layer of carbon dioxide ice that turns to gas every Martian summer. A dune field that's speckled with oval-shaped mineral deposits. A 35-kilometer impact crater in the Vastitas Borealis region that covers much of the far northern latitudes. The crater has a maximum depth of roughly 2 kilometers beneath the crater rim. It contains a permanent patch of water ice that is present all year round, as the temperature and pressure are not high enough to allow the frozen water to escape into the atmosphere. The poles on Mars are known to contain large quantities of water ice. At the South Pole, the water ice is covered by carbon dioxide ice, commonly called dry ice. There is also ample water ice beneath the surface of Mars. As spring arrives on the northern hemisphere of Mars, dunes of sand near the pole as pictured here begin to thaw. The carbon dioxide and water ice actually sublime in the thin atmosphere directly to gas. Thinner regions of ice typically defrost first, revealing sand whose darkness soaks in the sunlight and accelerates the thaw. By summer, spots will expand to encompass the entire dunes. The Martian North Pole is ringed by many similar fields of Barcan sand dunes, whose strange, smooth arcs are shaped by persistent Martian winds. Curiosity Mars rover captured this image of Mount Sharp in the morning on October 13, 2019. The panorama is composed of 44 individual images stitched together. This mid-afternoon panorama was captured by Curiosity rover from a location on top of Naukluft Plateau on lower Mount Sharp. The foreground and middle distance show a geologic scene dominated by eroded remnants of a finely layered ancient sandstone deposit. The sandstone here appears to be dominated by thick layers of wind-blown sand, suggesting that these deposits formed in a drier epoch. These rocks resemble the type of rocks that a dune field like the Bagnol Dunes would form if buried. Some drifting clouds, which are likely water ice clouds about 19 miles above the surface. They are also noctilucent clouds, meaning they are so high that they are illuminated by the sun even when it's night at Mars' surface. The details of the central mesa inside Hibis Chasma are seen in close-up detail in this perspective view. A horseshoe-shaped chunk has been taken out of one side of the mound seen left in this image, and the material has slumped down onto the floor of the valley below. A dark patch appears to pool like spilled ink across the debris. It is most likely loose material that has slid down the walls from an intermediate layer. Melted ice could have played a role by weakening the rocks to create its floor-like appearance. Along the side of the mound, fine horizontal layering is seen. The layers likely comprise a mix of wind-blown dust and ancient lake sediments along with remnants of the older plateau. A panoramic photo taken by Spirit Rover from Gusev crater, looking up a slope and across rippled sand deposits in a dark field called El Dorado. This look back at a dune that NASA's Curiosity rover drove across was taken by the rover's mast camera. The rover had driven over the dune 3 days earlier. For scale, the distance between the parallel wheel tracks is about 9 feet. The dune is about 3 feet tall in the middle of its span across an opening called Dingo Gap. This view is looking eastward. This is Apollinaris Patera, an ancient shield volcano. The volcano measures approximately 180 by 280 kilometers at its base and rises to a maximum of 5 kilometers above the surrounding terrain. Shield volcanoes are large volcanic structures with gently sloping flanks. The caldera of Apollinaris Patera takes the form of a large crater approximately 80 kilometers in diameter and up to 1 kilometer deep. Volcanic calderas are formed when a volcano explodes or when the cone collapses. This image was originally meant to track the movement of sand dunes near the North Pole of Mars, but what's on the ground in between the dunes is just as interesting. The ground has parallel dark and light stripes from upper left to lower right in this area. In the dark stripes, we see piles of boulders at regular intervals. What organized these boulders into neatly spaced piles? In the Arctic back on Earth, rocks can be organized by a process called frost heave. With frost heave, repeatedly freezing and thawing of the ground can bring rocks to the surface and organize them into piles, stripes, or even circles. On Earth, one of these temperature cycles takes a year, but on Mars it might be connected to changes in the planet's orbit around the Sun that takes much longer. The twin peaks seen in the background in this image are modest-sized hills to the southwest of the Mars Pathfinder landing site. The peaks are approximately 30 to 35 meters tall. The scene also includes bouldery ridges and swells of flawed debris. This view from the mast camera on Curiosity rover shows a site where two different types of bedrock meet on lower Mount Sharp. The paler part of the outcrop in the foreground is mudstone similar to what Curiosity examined in 2014 and in early 2015 at Pahrump Hills. The darker, finely bedded bedrock higher in the image and overlying the mudstone is sandstone called the Stimson Unit. This is the South Polar Residual Cap, the part that lasts through the summer, which is composed of carbon dioxide ice. Although the cap survives each warm summer season, it is constantly changing its shape due to sublimation of carbon dioxide from steep slopes and deposition onto flat areas. Mars' North Polar Layer deposits comprise a thick stack of icy layers. Part of this image from NASA's Mars Reconnaissance Orbiter has lingering seasonal frost, which serves to accentuate those layers. An additional rationale for this observation is to document new activity in scarp erosion. A pitted outcrop called Point Lake is seen here in the upper half of this image. The outcrop as seen from this angle is about 7 feet wide and 20 inches high. The texture with its voids or cavities sets Point Lake apart from other outcrops in the vicinity. A closer inspection may yield information about whether it is a volcanic or sedimentary deposit. Curiosity rover shows detailed texture in a ridge that stands higher than surrounding rock. The rock is at a location called Darwin inside Gale crater. The camera was positioned about 10 inches from the rock. Scale is indicated by the Lincoln penny shown beside the mosaic. The ridge resulted from a crack or vein in the surrounding rock becoming filled with material that was subsequently more resistant to erosion than the material of the surrounding rock. This pair of images shows sand moving under Curiosity rover one day to next. The day apart images were taken as a part of investigation of wind's effects during Martian summer, the windiest time of year in Gale crater. The InSight lander on Mars. With its solar panels, InSight is about the size of a small bus. Its main objective on Mars is to detect seismic activity. The two prominent mesas in this view from NASA's Curiosity Mars rover are about 260 feet apart. The Rover Environmental Monitoring Station, nicknamed REMS on Curiosity rover, includes temperature and humidity sensors mounted on the rover's mast. One of the REMS booms extends out from the mast in this view. The monitoring station has provided information about air pressure, relative humidity, air temperature, ground temperature, wind, and ultraviolet radiation in all Martian seasons and at all times of day or night. Curiosity rover took this image showing part of the bite left in the ground when the rover collected a scoop of Martian soil. A cloud of soil near the top center of the image contains a light-toned particle. The observation that the particle is embedded in the cloud led scientists to assess this particle as Martian material, not something from the spacecraft. A close-up view of a rock named Tintina taken by Curiosity rover shows interesting linear textures in the bright white material on the rock. The size of the rock is roughly 1.2 inches by 1.6 inches. A rock called Burwash. The rock has a coating of dust on it. The coarser visible grains are wind-blown sand. This mosaic of Hibis chasma is composed of 8 single images taken from Mars Express. Hibis chasma is an enclosed, almost 8 km deep trough stretching 315 km in an east-west direction and 125 km from north to south at its widest point. It sits about 300 km north of the vast Valles Marineris Canyon. More than a dozen lava coils can be seen in this image in a volcanic region called Cerebrus Palus, which is about 500 meters wide. A lava coil is a spiral or scroll-shaped lava formation that occurs when relatively low viscosity lava solidifies along a slow-moving shear zone in the flow. The shear produces an instability that forms spiral-shaped patterns. Depending on the side of the flow, the spiral is clockwise or anti-clockwise. This image shows an inclined layering known as cross-bedding in an outcrop called a cellar. Cross-bedding here is an indicative of sediment transport in stream flows. Currents mold the sediments into small underwater dunes that migrate downstream. When exposed in cross-section, evidence of this migration is preserved as strata that are steeply inclined relative to the horizontal, thus the term cross-bedding. This panorama from the Mars Pathfinder lander includes twin peaks on the horizon and the Sojourner rover next to a rock called Yogi. Though Sojourner was only the size of a microwave oven, its six-wheel mobility system and its portable instrument for checking the composition of rocks and soil were the foundation for the expanded size and capabilities of later Mars rovers. Some dune fields located among canyon wall slopes, also known as wall dune fields. On Earth and Mars, these type of dunes are largely controlled by what is called microtopography. Physical obstacles can accelerate and decelerate airflow, create turbulence, potentially enhancing erosion, deposition, and or transport of dune sediments. This type of dune morphology is relatively rare across Mars. However, they are frequently located among the walls in the melas and Cooperates chasmata. The Cerberus fossae are a series of semi-parallel fissures on Mars formed by faults which pull the crust apart in the Cerberus region. They cut through impact craters, hills, and volcanic plains along the way and were formed less than 10 million years ago. They stretch for 1,235 kilometers from the northwest to the southeast. Sandstone layers with varying resistance to erosion are evident in this Martian scene recorded by Curiosity Mars rover. Differing degrees of resistance to erosion result in a stair-stepped pattern visible here. Steeper steps result from more resistant rocks, so the flat tan surface is a weakly resistant sandstone. The small steps to the right center are a bit more resistant, and the steeper steps near the top of the scene are even more resistant. The Namib Dune on Mars. While most sand on Earth is made from the mineral quartz, which is white and bright, on Mars most sand is composed of dark basalt, a volcanic rock. Barken dunes on Mars as seen by HiRISE on the Mars Reconnaissance Orbiter. This animation shows carbon dioxide ice sublimating, going directly from a solid to a gas inside a pit at Mars's south pole. As ice is lost from the steep walls of pits like this, it reforms on nearby flat surfaces. This 360-degree mosaic from the mast camera on Curiosity Mars rover looks out over a portion of the Bagnol Dunes which stretch for several miles. The dark rippled surface of a linear dune is visible at the center of the view and receding into the distance to the left. The bedrock of the Murray Formation, made from sediments deposited in lakes billions of years ago, is in the foreground along with some components of the rover. The location called Ogunquit Beach is on the northwestern flank of Lower Mount Sharp. A detailed panorama from the mast camera on Curiosity Mars rover shows a view toward two areas on Lower Mount Sharp chosen for close-up inspection: Mount Shields and Logan Pass. The Martian North Polar Layer deposits are an ice sheet much like the Greenland ice sheet on the Earth. Just as with the ice sheet in Greenland, this Martian ice sheet contains many layers that record variations in the Martian climate. Sometimes icy layers can be ablated away during warm climates. Later, the ice sheet can be buried by new ice layers and grow in size again. It's likely that many of these cycles have occurred over the ice sheet's history. Fluctuations in the thickness of the ice sheet are most pronounced at the edges of the sheet, where this HiRISE image was taken. What created this unusual hole in Mars? The hole was discovered by chance in 2011 on the dusty slopes of Mars' Pavonis Mons volcano. The hole appears to be an opening to an underground cavern. It is about 35 meters across, and the interior shadow angle indicates that the underlying cavern is roughly 20 meters deep. Why there is a circular crater surrounding this hole remains a topic of speculation, as is the full extent of the underlying cavern. Holes such as this are of particular interest because their interior caves are relatively protected from the harsh surface of Mars, making them relatively good candidates to contain Martian life. This image shows the permanent polar cap of Mars, encircled by sand dunes and looking like pulled threads. These dunes march across a fabric of patterned ground. At this time of the Martian year, the dunes are free of the seasonal dry ice that forms a temporary cover every winter. This image is centered on Utopia planitia along the north seasonal polar cap edge in the late northern winter and shows a dust storm on Mars. The image also shows the seasonal north polar cap at top of figure and gravity wave water ice clouds coming off Mile crater just south of the storm. Gravity wave clouds, also called Lee wave clouds, are clouds that result from changes in atmospheric pressure, temperature, and height because of vertical displacement, such as when wind blows over a mountain or a crater wall. Deimos, meaning panic, is the smaller of the two Martian moons and is less irregular in shape. Deimos is about 12 kilometers in diameter and its orbital period is 1 day 6 hours and 17.9 minutes. Although both moons are heavily cratered, Deimos has a smoother appearance caused by the partial filling of some of its craters. Thanks for watching, and don't forget to like, share and subscribe.